Welcome to this video, and here we're going to do the second way in which we can differentiate a function. In our previous video, we have talked about how we can differentiate a function by chain rule, and here we're going to talk about the product rule of differentiation. How would we differentiate using the product rule? Now, just to mention that if you want to differentiate by product rule, then you're talking about those two functions that are multiplied together. So if you want to apply the product rule, then it is best used when you have two functions that are multiplied. Now, it's good to note also that you can multiply those functions and expand them for you to be able to use other rules of differentiation. But now, the best way to differentiate functions that are multiplied is by product rule. Now, if you have two functions, y and that is y equals to uv, that is the function of y with respect to x. These two functions are with respect to x. So the first function is u, the second function is v. So if you want to find the derivative or the first derivative of those two functions, then you take the first function u, multiply by dv. dv means the derivative of the function v, and then you add that to v. That is, v is the function v, multiply by du. du is the function of the first, or du is the derivative of the first function. So it is very simple. u dv plus v du. If you write this and then memorize, it's going to be very easy for you to remember that. Now, this is of course my lecturer taught me how to do it, and he told me that if you have it as u dv plus v du, then it's going to be very easy for you. Now, let's apply it in these two examples and see how it's going to work out. Now, you have a function, and of course this is a function of y. It's good you remember that. We have y is equals to x squared plus 2x. That's the first function, and the second function is 3x squared plus x. And we are supposed to use the product rule to differentiate this function. So of course, it's going to be very easy. Y prime, of course, which is good if we can have them highlighted as u and v. Of course, we know we're going to have u dv plus v du. That means the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. So the first function is u, then you have it as, so y prime is going to be equal to x squared plus 2x, and we multiply that by the derivative of the second function, which is the derivative of the second function is going to be 2 multiplied by 3 is 6, and then x, subtract 1 from the power, going to be 1, and then plus the derivative of x is 1. Now we add that to v du. V is 3x squared plus x, and we multiply it by du. du is the function of, or the derivative of the first function, that is going to be 2x plus 2. That becomes the derivative of our function. It is good if we can simplify further. So that's going to be equal to, now we can have this as 6x multiplied by x is 6x cubed, then plus x squared plus 2 multiplied by 6 is 6x squared plus 2 multiplied by 1 is 2x plus, and we can also simplify this. So 3x squared multiplied by 2x is 6x cubed, then this multiplied by 2 is going to be equal to 6x squared plus, now we are here, x multiplied by 2x is 2x squared plus 2x, because 2 multiplied by x is 2x. Now we can see whether we can simplify it further. So that's going, I just expanded this. If you write it, it's going to be very easy, but if you can follow very closely, then it's going to be very easy as well. So the like terms are, now we have a cube here and a cube here, that is 6 plus 6, that's going to be 12x cubed, and then we have a square here, a square here, a square here, and a square here. So the 1 square plus 6 square is 7 square plus 6 square, and then 2x, that is going to be 4x. And that becomes the derivative of our function here. You can see how easy it is to work out using the exchange rule or the product rule. Well, so let's do this example here. Looks very easy. So this is u and this is v. So if we take the first function x squared, so y prime is going to be equal x squared multiplied by the derivative of the second function. So the derivative of the second function is 12 x raised to 2 plus 2, and then plus the second function, which is 4x cubed plus 2x, multiply that by the derivative of the first function, which is 2x. And that becomes the derivative. So what remains is for us to simplify further. So let's see. So we can open this bracket, which is equals to, it's going to be 12x power 4 plus 2x squared plus this is going to be 8x cubed plus 4x, not cubed here, that's power 4, plus 4x squared. Right. So finally, we have a power 4 here, power 4 here, power 2, power 2. You can simplify that further. 12 plus 8 is 20. X power 4 plus 6x squared. So that becomes the derivative of our function. So what did we learn? That if you want to apply the product rule, then it is very easy to do that. If you have a function of y, which is the product of two functions, u and v, then you're going to take the first function u, multiply by the derivative of the second function, that is u dv. And then you add that to the second function v, multiplied by the derivative of the first function du. Of course, we have done an example for the same, u dv plus v du, for the two examples we have done there, and that's how it's done.